Right, let's get this session underway. For you listening, welcome to today's deep dive.
We have a highly specific objective for this analysis.
We do. We are conducting a forensic page-by-page review of the source document titled the Agentic AI Evolution.pdf.
And the mission here is to understand the structural shift from basic execution software to autonomous agentic workflows.
Exactly, and more importantly, the economic implications attached to that shift. So, establishing the protocol for this review.
We will proceed strictly chronologically through the slide deck.
Yes, I'll be taking the lead on identifying the core intent, the why of each section.
And I will follow up by breaking down the evidentiary what, extracting the specific data points from each slide.
Right, let's just dive straight into the material. Moving to slide 1, the heading is the Generative AI Revolution, from execution to creation to autonomous action.
The core thesis here.
It is. The slide argues that software is undergoing a structural shift comparable to the internet revolution. It's moving from being a mere tool to an operational engine. What is the data breakdown here?
The visual progression depicts three distinct phases. Phase 1 is traditional software, which the text defines as execution, specifically rules-based.
So deterministic systems.
Precisely. Then we move to Phase 2, generative AI. This is defined as creation or prompt-based.
Right.
And finally, Phase 3, which is agentic AI. This is defined explicitly as action, and the key descriptor is autonomous.
There is a notable vector illustrated on the slide as well regarding that progression.
Yes, there's an arrow indicating increasing complexity and autonomy across these phases. And the ultimate goal stated at the terminus of this arrow is the transition from user to builder.
Which sets up the business case perfectly. Proceeding to slide 2, the heading reads, the economic imperative, market demand and salary premiums.
This is where the quantitative data gets particularly instructive.
The intent here is to frame the business justification for adopting this technology, focusing heavily on an explosion in market demand. Walk us through the hard numbers on these charts.
The job growth curve is significant. The baseline in January 2021 is just 55 postings. By May 2025, the projection reaches 10,000 postings.
Which this slide explicitly highlights as a 200x growth metric.
Correct. The 200x multiplier is the focal point of the growth chart. Then, looking at the salary differential bar chart, we see traditional tech roles carrying a 3.5x premium.
But the disparity with non-technical roles is the real data point.
It is. The chart shows non-tech AI roles commanding a 7x premium.
With the average base salary listed at what?
The listed baseline is $116,000. The textual conclusion on this slide reinforces that generative AI skills are, quote, no longer niche, end quote, but rather a strategic baseline.
Understood. Let's move to slide 3. The heading is analysis versus invention, understanding the shift in capability.
This covers the architectural differences.
Right. The purpose here is explaining the fundamental difference in how modern models process information compared to legacy systems. Break down the two archetypes presented.
The slide contrasts traditional AI, which it labels as discriminative, against generative AI, labeled as creative.
And the descriptors for those.
Traditional AI is described as the critic. Its primary function is analysis and prediction. The specific examples cited are, is this email spam? And is this a cat?
So categorization based on existing parameters.
Exactly. Conversely, generative AI is described as the chef. Its function is invention and creation. The output capabilities listed are write a poem, generate an image, write code.
So synthesizing this, the distinction is that traditional AI identifies patterns in existing data,
Whereas generative AI utilizes those learned patterns to invent entirely new artifacts from scratch.
right, which requires a different mechanical approach. That brings us to slide 4. The heading is under the hood, transformers, how LLMs predict and generate.
The technical architecture.
Yes, this slide covers the underlying mechanics making these generative predictions possible. What is the technical process flow outlined here?
The slide uses a specific input string to demonstrate the flow. The input is a cat wearing sunglasses. The first step is tokenization. The system breaks the phrase into 4 distinct tokens, bracketed as A, cat wearing sunglasses.
And then the core mechanism takes over.
Yes, the self-attention mechanism. The diagram shows it as a web connecting distant tokens. Specifically, it highlights the connection between cat and sunglasses to establish the contextual relationship.
So it maps the dependencies within the string.
Correct. After that, we have the prediction phase, where the model calculates output probabilities. The slide shows a binary calculation, image at 99% versus text at 1%.
Leading to the final generation of the image.
Exactly. I should also note the specific training methodology listed at the bottom of the slide. It explicitly cites reinforcement learning from human feedback, or RLHF.
Right, the alignment layer. Moving sequentially to slide 5. The heading is From Chatbots to Agentic AI, the Evolution of Autonomy.
We're returning to the phase progression here.
We are. The core intent is summarizing the transition from systems that merely write to systems that actually act on behalf of the user. Detail the three-stage evolution diagram for us.
Stage 1 is generative AI, symbolized visually by a recipe book. The text defines it as the creator, noting it is limited strictly to content generation.
Content only, and stage 2.
Stage 2 is AI agents, symbolized by a microwave. It is defined as the doer. However, it is limited to executing a single task.
Which leads to the current frontier.
Stage 3, Agentic AI. The symbol changes to a smart home hub. It is defined as the orchestrator. The diagram shows the system connecting multiple nodes, specifically a microwave, fridge, and coffee maker, to achieve planning plus execution.
Now, there are specific technical specifications highlighted that enable that orchestration.
Yes, two specific additions are required for Agentic AI, a planner module and long-term memory. These are necessary to coordinate disparate tools autonomously over time.
Which requires precise instructional inputs from the operator. That transitions us to slide 6, heading, Prompt Engineering, the control panel.
The human interface layer.
Exactly. This slide describes the technical skill required to steer the model effectively and, crucially, eliminate hallucinations. Let's dissect the anatomy of a perfect prompt table.
The table breaks the prompt down into 4 mandatory variables. First is the role, cited as act as a physics teacher.
Defining the persona.
Right. Second is the task, which is explain quantum entanglement. Third is the constraint, listed as to a 5-year-old using a story metaphor.
And the final variable.
The format. The example given is output as a bulleted list with emojis.
Are there optimization strategies listed alongside that framework?
Yes, there is a sidebar detailing 3 specific strategies. Number 1 is chain of thought, which requires adding the phrase, think step by step.
To force sequential reasoning.
Correct. Number 2 is role prompting, using the act as formulation. And number 3 is few-shot prompting, which involves providing the model with prior examples before execution.
Instructive. Let's proceed to slide 7. Heading reads, Building with LangChain, Infrastructure for Production-Ready Apps.
We are getting into the middleware now.
We are. The slide explains a fundamental problem, which is that raw, large language models lack persistent memory and outside system access. Break down the LangChain ecosystem diagram.
The diagram positions LangChain as the necessary glue layer. In the center, we have the LLM, which is explicitly identified as the brain.
And orbiting that central node.
3 distinct components. Component 1 is tools. The listed examples are search, calculator, and APIs. Component 2 is memory, encompassing vector store and history.
And the third.
Component 3 is chains, which manage logic and sequence.
How does the workflow cycle operate according to the slide?
The cycle indicates that the user interacts directly with the chains. Those chains then coordinate the brain, the tools, and the memory simultaneously to build and run functional applications.
So it acts as the orchestration framework.
Yeah.
That naturally leads to the practical deployment phase on slide 8. Heading, Real-world applications, solving complex problems across sectors.
Moving from theory to practice.
Yes. The focus here is the shift from novelty usage to high-impact enterprise problem-solving. Itemize the 4-sector impacts detailed in the quadrants.
Quadrant 1 is development. The application is agentic coding and debugging. The specific commercial example cited is GitHub Copilot.
Quadrant 2.
Healthcare. The applications listed are synthetic data generation and diagnosis summaries.
And the 3rd sector.
Data analytics. The use case is defined as chat with data. The explanation provided is translating natural language to SQL queries.
Finally, the business sector.
Sector 4 is business, specifically autonomous workflow automation. The cited example here is Shopify Sidekick.
So we have broad, autonomous operational integration across multiple verticals, which necessitates slide 9, heading, ethics, risks, and responsible AI. The human in the loop.
The governance protocols.
Right. The thesis here is that enterprise deployment requires robust, non-negotiable guardrails. Detail the 4-part security layer diagram.
The diagram positions the AI model output in the center, surrounded by 4 distinct barrier walls.
Let's go through them directionally as shown.
The top barrier is the fairness check, functioning as a bias filter. The right barrier is fact verification, specifically relying on RAG grounding.
Retrieval augmented generation. And The bottom.
The bottom barrier is data privacy, operating as PII redaction, and the left barrier is human oversight, labeled as the validation layer.
Are there specific threat vectors mentioned that require this infrastructure?
Yes, the text explicitly mentions two requirements: the need to manage system hallucinations and the imperative to prevent, quote, prompt injection attacks, end quote.
So security remains a primary structural concern, not an afterthought. Which brings us to the final page of the document. Slide 10. Heading. The roadmap. Skills for the future. Preparing for the agentic era.
The synthesis of the necessary human adaptations.
Correct. The core theme identified here is text to action. Walk us up the career roadmap staircase detailed in the graphic, starting from the bottom.
Step 1 at the base is Python and ML basics. Moving up, Step 2 is prompt engineering.
Then the infrastructure layer we discussed.
Yes. Step 3 is building with LangChain. Step 4 is mastering agentic workflows.
And the summit of this progression.
The summit is labeled strategic agility.
There's a specific definition provided for that top-tier skill, correct?
There is. It defines the number one skill, agility, as, quote, the ability to unlearn and relearn, end quote.
Which concludes the chronological analysis of the slide data. To synthesize our findings, I will read the concluding motto explicitly stated at the bottom of the final slide.
Go ahead.
Quote, collaborative intelligence. Humans bring creativity. AI brings scale. End quote.
That aligns precisely with the data we've reviewed. We can confirm the forensic review of the Agentic AI Evolution.pdf is now complete.
It is. So, to you, the listener, as you process this data regarding the transition toward autonomous systems, consider this. If the software is now capable of executing complex workflows, and your value relies less on execution and more on orchestration, what specific operational problem in your current environment are you uniquely positioned to define and delegate to an agentic system? Something to evaluate.
Indeed. We will close the session here.
Thank you for joining us for this deep dive. We will analyze the next data set with you soon.